What's up, guys? How you doing? Hey, we got back to the demo part. So here we are. This is the demo of our cooler controller that we're going to be working with here. As you can see, I've got a receptacle that I've just mounted in. Just took a hole saw and cut it out. This little plastic box I just got from my local hardware store. It's kind of neat because it's got little mounting points on it right here, so you can mount it. That's on both sides, so you can mount it to your cooler. I've gone ahead and taken the screws out of it and popped it apart. All I did was I just used a, I used a Dremel tool and the, one of those like wood hole saw cutting, kind of like a router or a rotozip bit to route out a little hole here for the LCD screen. And so let's go ahead and I'll flip it over and we can see what's inside this little guy here. So let me make sure I don't hook anything or get anything sideways. Let's pop it all open here. Alright, we've got kind of a little rat's nest going on here, but that's alright. That's electronics for you. Alright, so what we got going on is obviously on the receptacle I've got the neutral and the ground, that's the white and green wires. And then on the other side you can't see it, but it's this red wire that comes from the hot side or the energized side of it. We've got our basic circuit down here. Let's see if I can zoom in here. Get this craziness. There's the microcontroller. There's our two resistors. What I did was I mounted a header on it so I could plug like a little power cable in to it. So it's got a little power cable. There's the transistor that's going to that's switching our FET, I believe, down in that. Well, no, you can't see it. It's kind of, there's the resistor for that transistor, the bleeding resistor, and then I don't think you can see it, but there's underneath there. There's also the blocking diode to protect it. So fairly easy circuit. I just stuck it down with some double back sticky pad. I don't know if I have any. Yeah, I have some. You can get some of this at your local electronics store, but it's basically, you know, that sticky pad. It's kind of a foam pad, but it's super duper sticky, and it's got two sides to it, and that's what I use to stick that down with. Now, one of the big questions is how do we, since we're bringing in AC power, that's what this cord is down here. We're bringing in AC power. How do we get the 5 volts DC to run this with? Well, that's what this little kind of hodgepodge on the side is. I don't know if you guys have laying around, but I have a ton of these little chargers. Oops, let's zoom out. Back up a little bit. A ton of these little chargers. Old phone chargers work the best, but these little chargers are like a little wall wart charger. You know, it's got the little micro USB on it. These work amazing. What I did was I just split this casing off of it, being very careful not to damage the components inside, but just broke this case off. And when I broke it off, I had this entire circuit that's down in here. And it has everything. It's even got overvoltage protection. It's even got the transformers to transform the AC down to a reasonable amount. And then it rectifies it out. So it's this big smoothing cap is for it. Rectifies that all out and everything. And on the back, at least of this one was one out of an old BlackBerry charger. On the back was 2 spots to solder wire onto. And let me see if I can pull this out. There's a little wire here. Let's see. There's a little wire here and a little wire over here. And those are the two that touch the plug-in prongs. So that's the AC right there. So all I had to do is just solder some wires to it. And voila, I got the AC. Of course, I'm bringing in AC down here with this wire. And I can bring the AC in, power this with AC. It gives me, that's what these little wires are here. This gives me the 5 volt DC. It gives me the 5 volt DC off the AC port. So I can power our board. And then also I have, the AC power to then power this up. So that's what we got going on here. Let's see if I can dig this other guy out. Ooh, excuse me for just a second. I'm going to blank out the camera. Okay. So here's our guys. Here's what we got here. Okay. So we've got 2 red wires, okay? This one and this one. Okay? These 2 red wires go down to our relay. That's the 2 sides of the relay in the schematic that I showed you before. That's the 2 sides of the relay. Okay, one side of the relay wires up with the incoming energized conductor, which is the black wire off of this wire that's down here that's coming in. This is the black. You're going to have the 3 wires. You'll have black, white, and you'll have a green that comes off of this this incoming wire. You can buy these also at your local hardware store. I've them referred to as a pigtail, but basically all it is it's just a plug. Let me see if I can grab the other end of it here. It's a plug. Just now, like I said, I'm using this is USA stuff, so basically stuff that's in the States. But what it is it's going to be the plug for, hang on just a minute, I gotta set this back down. And I'm losing battery on my camera. I need to plug that in right fast. So hang on just a second. I'm gonna plug my camera in so that way we don't lose our video feed here. So give me a second. It might jiggle around a bit while I do this. I didn't check it before we started. My bad. Okay, there we go. Now we don't lose our video. All right, but anyway, that's all it has. I'm using the USA plug, type plug, so it's just that little three-prong plug. European style and the different styles, you know, will be different plugs, but generally, at least here in the United States, you can pick these plugs up where they're the plug on one end and it's just a stripped out wire on the other end. They come in various lengths and all that stuff, so I just picked up one of those for this. And this is called a Romex connector. It just goes in and has a little lock nut that screws down, locks it in place, and then you can feed the wire through and then screw it down, then it's solid. So that's just called a Romex connector, is all that is. But anyway, back to what we were talking about. One side of the relay will go to the energized conductor, which is the black on this cord that I've got. Also, the one side of our wall wart, essentially, that we've taken apart, this little power supply, will go into it as well. So that way all of those get the energized 120 volt AC. Okay? That's it for that one. This is just called a wire nut. You just screw it on and screw it till it's tight, till it's good and tight. I like to screw it till the wires begin to twist. See how they begin to twist up around themselves? That's how you know you'll have a good connection. And then what I usually do is kind of tug on the wires. Not hard, but just kind of pull on them a little bit. Make sure that they don't slide back out. Because that's called a slip joint. You don't want a slip joint, otherwise it'll slip out in there and then all of a sudden stuff stops working and you don't know why. Now, we move on to the neutral side, which will be the white wire coming from that cord. And all the neutrals will go together. So you're going to take from your receptacle, okay, the neutral from your receptacle, which that is the silver screw. There will be a silver screw, and then on the other side, I may flip this over in a minute, but on the other side there's a copper-looking screw. The silver screw is the neutral. The copper-looking screw is the energized side, okay? So the hot, or the black wire, technically, is what's on the other side. So anyway, so white wire goes to the silver screw. And then by the way, just as another precaution, make sure that you do not have any of this plugged in while you are doing this, because you're dealing with AC current, and AC can hurt you. It can hurt you bad, and even 120 volt can hurt you, and it can hurt you bad. And a lot of people think that it's just 120 volts what's running around in your house, but it can hurt you. There's actually a good statistic for you, for those of you that like statistics. There's been more people killed off of 120 volt low voltages than any of the high voltage, 138 kVs and crazy stuff like that. It's the low voltage, because most people think that it's low voltage and it won't hurt you. So be very careful. AC current is mean. So make sure things are off when you're playing around in here, okay? So back to what we were saying. So silver screw white wire goes to the white wire coming from the cord. That's this wire right here. This wire is coming from the cord, as well as the other side to our wall wart, or our power supply, is going to go into this as well. And so I've put that on with a wire nut. Again, twisting it to make sure once they twist up, then we're good and tight. So that's basically that. So I just kind of push that down in there where it's where it's out of the way. Now comes the switch side. You always in any electrical circuitry. I've seen people do this in DC differently, but I'm just going to say, rule of thumb, always, whenever you're switching a circuit, switch the energized side. So if it's DC, switch the positive side. If it's AC, switch the energized conductor, or what we call the hot conductor. Okay, so like this black conductor, that's what you want to switch. Okay, you do not want to switch the ground or the neutral, because what happens is when you switch the ground or the neutral side, now you're providing the electricity a way to where it can seek out a ground, which generally is your finger. You know, you get your finger in there or something, and if the ground has been removed, or in the AC case, the neutral has been removed, if you're touching something metal and your finger touches in there, it's going to take you to ground, which hurts. Okay? That equals pain. So always make sure that you switch the high side. That way, if there's for some reason something happens where the switch is open when it shouldn't be or something like that, it's only just breaking the high side and it's not looking for a ground. Okay? You can touch the neutral, you know, well, at least in DC, you can touch the ground, and the ground's not going to hurt you. And generally, in AC, the neutral is not going to hurt you unless you crack a neutral open and you spread the wires apart under a neutral. Like if I were to take that wire nut off of that neutral and spread all the wires apart and then touch the wires, there could be a potential that there could be a different circuit somewhere that could take you to ground through the neutral. So you want to be a little leery of neutrals also. So just be careful of neutral, but I always definitely recommend you switch the hot side of things. That way, if you know that everything's de-energized, then you don't take a chance on getting hurt. So anyway, what we're going to do now is the other side of the relay, which is this wire, okay, comes from the other side of the relay. We're going to wire that in with the other side of the switch, which now I'm going to try to roll it over. We'll try to roll this over. See, there's a kind of a copper colored screw. That is what's going to wire to the other side of the relay, because that is the switched side of the relay. See? So basically, the hot, which is over here, the hot coming in from the wall, goes to one side of the relay, and then the other side of the switch relay goes to our, and we'll twist that on nice and tight. Pull on it. There, it's good. So, and that goes to the other side of our receptacle. Okay? So, fairly straightforward. If you have any questions, you can always ask me. But that's basically how that works. And then what I did was I just made sure all my wire nuts and everything that's big and bulky all tuck over to the side, you know, away from the circuitry. I don't know if you can see that here. Let me turn it. See? So everything kind of tucks over here. That way when I close it up, I'm not smashing anything. Okay? And then as you can see out the top here, I don't know if you can see this white little thing. That's our thermistor. At least that's the one that I bought. See, it has this kind of little plastic end on it. That's our thermistor, and that comes in and solders to that bottom board. So now we can go ahead and close it up. Put this on. Of course, it's going to be kind of stiff. And it comes with 4 little screws. Here, let's back off a little bit. Yeah, so we can see. It comes with 4 little screws, and I recommend doing the torque way of things. Do each corner first, and then, you know, don't go around a circle, because this does have a little seal in it, which is actually kind of nice. That way, if this is going to be out in your garage or something, this is going to be out in your garage or something, you know, it could get sprayed with water or something, you know, or could have goop dropped on it. So it does have a little seal. You could put a little gasket around this. I just used a hole saw to drill that out with, and I mean, it wasn't really the best thing. It wasn't exactly the perfect size, but you know, you work with what you got, right? So let's go ahead and get this sucker back together, and we'll show you how it works. So, okay, all right. So now we're all back together. Let's go ahead and see if we can't power it up. I'm going to stop the camera because I think I'm going to kind of reset up a little bit, and we'll demo this here in just a second. So hang on just a minute. Okay, hi guys, I'm back. Just looking around, putting the finishing touches on everything. What I'm going to do is sorry it's going to get dark, but I'm going to unplug my light. That way I can show you guys that this actually does work. We got it all powered up and everything. Plug it in here. There we go. Hooray! Which obviously the light's going to be on because it is way above 5 degrees C, so it's going to be trying to turn the... this receptacle is going to be on because it's like turning on the, whatever it is, turning on the freezer, refrigerator, whatever you want to call it. So essentially, as you can see, I've got it set for 5 degrees C. Right now it's about 24.9, and that's pretty much right. We got, it's about 25 degrees in here right now. So what I'm going to do is I've got a device that is going to cool down our little temperature probe, and you should see that happen, and we should see the light go off once it gets cool. So I'm going to go ahead and turn that device on. So hopefully it should be getting cool. Yeah, it looks like it's going to. Looks like it's getting there. As you can see, the temperature's going down. Pretty soon, once we get under, there it is. When we get under 5, I don't know if you guys can see that, but we're about 4 degrees, which is shut that. Of course, mine, I haven't, that software, if it goes below, like way below 0, which I've got it hooked up to a Peltier junction right now, I'll just be honest, so it's making it way, 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 way cold, and so it doesn't go negative. So you might want to add that to the software, but it doesn't go negative. So if you got negative, then you have to deal with that. But now I'm going to let it warm back up by turning it off, which we should see this kind of rebound and start warming back up. In a minute. Here we go. There's 5 degrees. You should see the light come on once we get past 10. There it is. Once we got past 10 degrees, we got the light come back on. So there you go. It does work. So the code does work. Like I said, we found that spot where if it goes negative, it'll have issues. So you might want to throw that into the code. But anyway, more or less, there is a refrigerator, freezer, keyser, however you want to call it, controller. So guys, I hope you enjoyed this. I sure did. I'm going to definitely use this, actually, is what I'm going to do. But that's how you create your own cooler controller for around, oh, I don't know, by the time this was all over with, maybe, I don't know, 20 bucks maybe, around $20 roughly. I don't know, just have to see. Of course, a lot of the stuff I had was just laying around, but one of you can probably do the math on it and see what all this stuff would cost you. But it's definitely not the 150 bucks that you see online cooler controllers for. So definitely helps you out. So guys, throw some likes and some subscribes, and please share this video. Check me out on Twitter. I do post stuff there. Like I said in the last video, I do post things there if things are going to be late or new upcoming things, or just some stuff that I run across that is pretty cool. I'll maybe snap a picture of, throw it up on Twitter. So benefit you to subscribe to me there. All right, guys, that's it. That's all I had. Take care. Happy coding. And keep doing it, because, you know, that's what it's all about. The fun of doing it. All right, guys. We'll catch you later. That ought to do it.